Welcome to Get Your FRQ On. This is from the 1999 Calculus AB exam. It is question 3 and it is calculator active. In part A, we are asked to use the given table and 4 midpoint sum rectangles to approximate the definite integral from 0 to 24 of r of t dt, and then to explain its meaning. Since we're given the table and given a specific method to use, we have to use the method indicated. So we divide the given interval into 4 equal subintervals, which is the expectation if it is possible. The sum will then be determined by the values at the middle of each interval, which in this case would be r of 3, r of 9, r of 15, and r of 21, along with the widths of those intervals. So our approximation for the integral from 0 to 24 of r of t dt would be 6, since all of the intervals are of width 6, times the sum r of 3 plus r of 9 plus r of 15 plus r of 21. Those 4 values we get directly from the table, and since this is a calculator active, we can actually determine a number here. The value of the integral would be 258.6 gallons. And what this means is that definite integral, the value 258.6 gallons, is an approximation of the total water flow in gallons coming out of the pipe over the 24-hour period. In part B, we are asked if there is a value of t between 0 and 24 such that r prime of t is equal to 0, and to provide a justification. This feels like a mean value theorem question, and in order to use the mean value theorem, we first have to verify that the hypothesis or the conditions necessary for the mean value theorem are met, and that means we have to show or somehow explain that r of t is continuous and differentiable on that interval. This is easy to do. We're given in the given information that r of t is differentiable, and so if r of t is differentiable, it must be continuous. And then from the table, we see that r of 0 and r of 24 are both 9.6. So if we find the average rate of change between 24 and 0, we get r of 24 minus r of 0 over 24. But 9.6 minus 9.6 will just get us 0 again. So yes, there is a value of t between 0 and 24 where r prime of t is equal to 0. The mean value theorem guarantees this. And just a reminder, you don't actually need to state that you're using the mean value theorem. You just have to use the mean value theorem. You have to verify that the conditions for the mean value theorem are satisfied, and then you have to show whatever the conclusion would be, but you don't have to name the theorem that you're using. In fact, if you name a theorem when you're justifying a conclusion and the name of the theorem you give is not the correct theorem, you can lose at least 1 point for the incorrect theorem. The purpose of these questions is to test your ability to use the theorems, not how well you remember their names. In part C, we are given a function q of t and asked to approximate the average rate of flow for the 24 hours and give the appropriate units. So we're given that r of t is approximated by this function q of t, 1 over 78, times 768 plus 23t minus t squared. The average value of r of t can be found using the mean value theorem for integrals. So basically we're just finding the average value of the function over that interval by finding the value of a definite integral and dividing by the length of the interval. All right, so the average value of r of t would be 1 over 24 times the definite integral from 0 to 24 of q of t dt, And since this is a calculator active question, you should use your calculator to evaluate this integral. Yeah, you can do it by hand, but it's going to take a lot longer. And with the free response questions, you really don't want to use more time on any part than you have to. So use your calculator for this. Enter the function q of t into your y equals editor. Use the integration tool on your graphing calculator. And the definite integral turns out to be 10.785 gallons per hour. And you do have to give the precise units since it is asked for. If it is asked for, you do need to do it. You can lose a point if you don't do it. If it's not asked for, you generally don't have to do it. But you should probably get in the habit of providing the correct units anyway.